All right, so let's finish up chapter 10 and do our final screencast on the last phase of photosynthesis, which is the Calvin cycle. So thus far, we've gone through the light reactions and transformed the light energy of sunlight into chemical energy in the form of ATP and NADPH. And the Calvin cycle is going to use that energy to reduce carbon dioxide, i.e. add high energy electrons, and change it into high energy storage sugars. Okay, so the Calvin cycle, like the citric acid cycle, is a cycle, so it regenerates its starting material. Okay, the cycle builds sugars from smaller molecules using ATP as an energy source and the reducing power carried by NADPH, which is those high energy electrons that got energized from chlorophyll converting light energy into chemical energy. Okay, so how the Calvin cycle works. Carbon enters the cycle as carbon dioxide and leaves as a sugar named glyceraldehyde 3-phosphate. And if you remember, this is one of the intermediates in glycolysis, G3P. So G3P is a 3-carbon sugar, and glucose is a 6-carbon sugar. So it takes 2 molecules of G3P to make 1 molecule of glucose. Okay. To get 1 G3P, the cycle needs to take place 3 times, fixing 3 molecules of carbon dioxide into that 3-carbon compound. The Calvin cycle has 3 distinct phases. The first phase is carbon fixation. Okay, and fixation means to take an unusable source and turn it into a usable. So carbon dioxide as a fuel for us is totally unusable, but we're fixing it into sugars, which is a usable carbon source for us. Carbon fixation is catalyzed by this enzyme called Rubisco, which I'll talk about more on the next slide. And then the second phase of the Calvin cycle is reduction. Okay, so this is where we add the energy in ATP and NADPH to our carbon molecule. And then the last phase is regeneration of the carbon dioxide acceptor, which is what we need to start the cycle again, which is RUBP, or ribulose bisphosphate. Okay, so let's have a look. Okay, so here we have our carbon dioxide coming in. Okay, and we have 3 total coming in to make our 1 G3P. And they will be attached to 3 separate molecules of our carbon acceptor, which is ribulose bisphosphate, or RUBP. Okay, so these guys come in. This is a 5-carbon compound. Carbon dioxide is 1 carbon at a time. So we're going to attach that 1 carbon onto the 5-carbon right there to make a 6-carbon compound. Okay. This is catalyzed by the enzyme Rubisco, and Rubisco stands for ribulose bisphosphate, RUBP, carboxylase. Okay, and again, it's an enzyme that adds carbon dioxide onto RUBP. Okay. So that gives us, so we've got 3 over here, 3 over here. That gives us 3 6-carbon compounds, and they are quickly changed into 6 3-carbon compounds. Okay, and then at this point, we've fixed our carbon, and now it's an organic molecule, and now we're ready to pack in some energy. So we're going to the next phase, phase 2, which is reduction, where we store energy into this 3-carbon compound. And this 3-carbon compound is phosphoglycerate, or 3PG. And if you go back and look at glycolysis, you will also see this molecule in glycolysis. Okay. And at this point, we just start packing the energy in. And that's what this whole reduction phase is all about. Glucose is a very high energy compound. It stores a ton of energy, and this is where we store it. This is how we store it. So 6 ATPs from our light reactions get packed into 3-phosphoglycerate and turn it into 1,3-bisphosphoglycerate, something else you will also see in glycolysis. Then 6 NADPHs, also from the light reaction, okay, they become oxidized and they reduce 1,3-bisphosphoglycerate, a reduction. So the high energy electrons get transferred from NADPH into 1,3-bisphosphoglycerate, and the end product is 6 molecules of glyceraldehyde 3-phosphate, or G3P. Okay, now at this point, one of these molecules of G3P exits the cycle. Okay, it waits around for a second one to form glucose and other organic compounds. Okay, so this is where we go to form glucose, right? So that's 1. So that leaves 5 G3P to continue on in the cycle. And those 5 G3P are used, here they are, to regenerate our carbon dioxide acceptor, which is RUBP. Okay, and through a process of several reactions, which you do not need to know, plus the addition of more ATP from the light reactions, and this is where that excess of ATP needs to come from, that cyclic phosphorylation, cyclic electron flow helps with. We regenerate 3 molecules of ribulose bisphosphate. Okay, and then it's ready to go back in, accept some carbon via Rubisco, and start the whole phase again. Okay, so it's important to follow the carbons. Okay, 3 times 5 plus 3 equals 6 times 5. 6, 5. Nope, sorry, that was bad math. Equals 3 times 6 carbons here. Okay, and then that 6-carbon compound gets broken apart into 3-carbon compounds, so we have 6 3-carbon compounds, and then that gets reduced into G3P. 5 of the G3P get used up to regenerate 3 5-carbon compounds of RUBP. All right, so each phase, you got carbon fixation, reduction, and regeneration of the acceptor. Okay, make sure, again, you don't have to know all the details of the names and everything like that, but you do need to know how we get the energy in glucose and where that G3P exits the cycle so that it can form glucose. All right, and that basically is photosynthesis. The end.